Mini lesson 3A, transformations. Transformations of a point. A linear transformation is defined as L of x comma y equals 4x minus 5y comma 5y. Find the coordinates of evaluate L of 4 comma 2. What we want to plug in for this expression for each of the coordinates is 4 for the x's and 2 for the y's. So 4 times 4 minus 5 times 2, comma, 5 times 2. That would be 16 minus 10, comma, 10. So our coordinates of the transformation is 6, comma, 10. Given point -4, comma 6, translate the point 9 right and 3 down, followed by a dilation by a scale factor of 2. Since we're translating the point directly, we don't have to change any sign, so 9 right will be plus 9. And it's going to be 6 minus 3. It says followed by a dilation by a scale factor of 2. That means that we multiply each of these answers by 2. So we have 2 times 5, comma, 2 times 3. Our transformation point will be 10, comma, 6. Which is the inverse of our first example. Matrix notation. T of xy, where T is the transformation matrix and xy is the transformation point xy. For matrices, your parent will be the 1, 0, 0, 1. That's the identity matrix. We can have a shear transformation with 1, kx, ky, 1, where kx is parallel to the x-axis and ky is parallel to the y-axis. An example of this one is that we could start as a square and then the transformation looks something like this, where these two are still parallel to that x-axis. And then for ky, if we change the ky to a different number, we'd start with that square again. And then we'd have a shape that looks kind of like this, where the lines are still parallel to the y-axis. For dilations, that's where you could dilate the x by a factor of dx and dilate y by a factor of dy. So you can either enlarge a shape or reduce the size. If you only change one of those two numbers, you could just stretch it either vertically or horizontally. Reflect across the x-axis. So you would start up here and then you go down there or vice versa. Reflect across the y-axis. You would reflect across the vertical line. And then reflect across y equals x. That's going to make a inverse. And then reflect across y equals negative x. So that'd be this way. And then for rotations, Here's the official formula for it. We have cosine theta, negative sine theta, and cosine theta. You'll mainly do basic rotations such as 180 degrees or 90 degrees, either clockwise or counterclockwise. So remember, this way would be clockwise, and then the other way, this way, would be counterclockwise. And for translations, you'll just take the point and either add or subtract those distances. So this one would be left is minus and then right is positive. Since again, we're directly changing the point, we're not changing an equation. Up is still plus, down is still minus. Function notation. The parent function is usually called f of x, and then the transformation will be g of x equals a times f of b parentheses x minus h plus k. All right, so let's go ahead and map out all of our transformations. If it has a minus in front of it, it would reflect across the x-axis. And then for the a, if not counting the negative sign, the a is greater than 1, it's a vertical stretch. If the a, not counting the negative sign, is less than 1, it's a vertical compression. If there is a negative outside of the b, you would reflect across the y-axis. And then for the b, if not counting the negative sign, that b is greater than 1, it's a horizontal compression. And if the b not counting the negative sign is less than 1, it's a horizontal stretch. Horizontal stretches become more horizontal, and vertical stretches become more vertical. For the h value, if we have a minus number, it's going to go right. And if we have a plus number, it's going to go left. For the k, if we have a plus number, it's going to go up. If we have a minus number, it's going to go down. Symmetry. How many lines of symmetry can you find for this image? Let's see, we have one right here. We have one right here. And then right here. And then 7, 8. Looks like we have 8 lines of symmetry. Shape transformations. Given the triangle, translate the points 9 right, 3 down, followed by dilation by a scale factor of 2. The first thing we want to do is identify the 3 points of this triangle. We have negative 7, 6, negative 4, 6, and negative 6, 2. We're going to transform each of these 3 points. There's 9 right, so that's going to be plus 9. 3 down, so it's going to be a minus 3, and then followed by a scale factor 2, so we're going to multiply those by 2. To get the new numbers, let's go ahead and find those. Negative 7 plus 9 times 2, comma, 6 minus 3 times 2. So this point, now let's do the next point. 2 times negative 4 plus 9, and then 2 times 6 minus 3. And then the last point, 2 times negative 6 plus 9, and then 2 times 2 minus 3. Let's find each of those 3 points and just list them at the top for now. So that's going to be 2 times 2, that's 4. 3 times 2, 6. And then we have 5 times 2 is 10. And then 3 times 2, that's 6. And then for the last point, we have 3 times 2, 6. And then negative 1 times 2 is negative 2. Once we've transformed all of the points, we can plot them on our graph. So 4, 6, 10, 6, and 6, negative 2. And then connect the points. Identify 2 types of transformations from dilations, reflections, rotations, and translations for each. From here, let's identify a point and a corresponding point to the other transform shape. This point is 9, negative 3. This one is negative 3, 9. So it looks like we have an inverse here. Reflect across. Y equals X. That's one possibility. Reflecting across the line y equals X is the same thing as rotate 180 degrees. And if you rotate 180 degrees, it doesn't matter if it's clockwise or counterclockwise. The next one appears similar, but instead of reflecting across the line y equals X, we're going to reflect across the line y equals negative X. And that would also be a rotation of 180 degrees. All right, so for this next one, from H to I, looks like it reflects across the Y, And then it's going to go to the right 4, and then down 11. And then another way that we can transform this is we can reflect it across the x-axis. And then make it go up 1, and then to the right 8. For the next one, we can reflect across the x-axis to get from P to Q. And then go down 4. Another possibility, you could go up 4 and then reflect across X. So to go from C to C prime, we could reflect across the y-axis. And so that would make it go right here. And then to get to C prime, we would then go to the left 7. Similarly, you could also go left 7 first and then reflect y. Okay, on this one, to get from A to A prime, we first rotate 90 degrees clockwise. And then go up 11. Or we could say that you rotate 270 degrees counterclockwise. And then up 11. Okay, so from this bigger one to the smaller one obviously has a dilation. Let's label our A's. So we're going to rotate 90 degrees counterclockwise. Then dilate by 1/3. So you reduce the size. You could also do this in reverse order, you would get the same thing. Or you could rotate 270 degrees clockwise. So for this one, it looks like it's going to be getting bigger and it's going to reflect. So we could write reflect y and then dilate 3. So it's going to be enlarged. And you can also do that in reverse order. Let's take one of these points. So for example, B is -3, 2. All right, so if we dilate 3, so multiply each of these by 3, that would be -9, 6. And then reflect y, that would change the x value to a positive. 9, 6. Is that where B is? 9 and then 6, that works. For this one, it looks like we're getting to have a larger image at the end. This one has a distance of 2, and this one has a distance now of 4. We just say we're going to dilate it by 2, and then we're going to have some kind of translation. If we multiply B, for example, 2, -1 by 2, we would get 4, -2. And then from there, we would want to go down 1, 2, 3, 4, 5, 6. We could also do this in reverse order, but it wouldn't be down 6. Our final B is, our B prime is 4, -8. If we went down 6 from here, that would already be way too large. Half of -8 is -4. From here to here, that's down 3. So we could also do down 3 and then dilate 2. On the last one, they give you transformation instructions and they want you to draw it. Given the triangle, reflect across the y-axis, followed by a dilation by a scale factor of 1/2. Okay, first let's reflect it across the y-axis and draw that picture. And we could put dash lines since we know that that's not the final picture. To have our dilation by a scale factor of 1/2, we're going to multiply each coordinate by 1/2. Let's identify the coordinate points first. 4, 6, 7, 6, and 6, 2. All right, so our new dilated points would be 2, 3, 3.53, and 3, 1. Let's plot those points on the graph. 2, 3, 3.53, and 3, 1. So your new picture would be right here. One thing that could really help you when you're trying to determine these transformations is just to take either a sticky note or a piece of patty paper or something to draw a picture of one of these original items and just move it around. Rotate it, reflect it. Or you could also copy and paste a picture of this onto some kind of drawing tool online, and you can move it around that way as well.